Hello, this is Mrs. Scarple, and in this video I'm going to review the definition of a function, identify some independent and dependent variables, also go over function notation and how we can describe different situations using function notation. So as a reminder, the definition of a function is that each input has exactly one output. So for every x value, there will be exactly one y value. X values tend to be our input values, y values tend to be our output values. Now I have this example here of we have time in hours and the number of steps taken each day. The independent variable is going to be the time in hours. And that's because when we're keeping track of our steps, we're generally basing it off of, well, how much time have we been awake during the day? So time in hours will be the independent variable, and the number of steps taken each day will be the dependent variable. That means when we go to graph this, the independent variable, or when we're even solving equations, the independent variable will be our input. And the number of steps taken each day will be the output. So independent, we can think input. Oops, would help if I could spell this. Here we go. Input. For independent, notice both words begin with the word in. And then dependent is going to be the output. Now we can also write this phrase identifying what is going to be a function of what. We always start this with the dependent. So in this particular situation, the number of steps taken each day is a function of the time in hours. When you're writing a sentence in this form with the phrase is a function of, we always start with the output. We say the output is a function of the input, the time in hours. Now, we've also talked about function notation in class. Function notation is a way for us to distinguish one function or equation from another. So the f that you see in this particular function notation is what we call the name of the function, or the function name. So just like you and I each have a name, our functions have a name. The t is going to be our input. So what's inside the parentheses, the variable that's inside the parentheses, is considered the input. Again, we've got a word that begins with the prefix in, inside. So inside the parentheses is the variable that represents the input. The entire notation, the entire function notation, represents the output. So what is my result? for my input? What is my result when I replace t with a time? What is my output going to be? So let's practice writing some things here in function notation. Here are some graphs. If you're in my Math 1 class, then you know that these graphs are from Elena's Mood app, and we had information about 3 different days. We had day 1, day 2, and day 3. I'm going to call day 1 my f of t function. So day 1 is f. T is the input, so that's the time. And you'll notice on the graph, time is along the horizontal or x-axis. Day 2, I'm going to call my g function. So this will be g of t. And day 3, I'm going to call my h function. So h of t. Now that I have named my functions, I can write some expressions to represent information given in these graphs using function notation. So here we have day 1, day 2, day 3. Again, I named day 1 f of t. I named day 2 g of t. And I named day 3 h of 3. So I'm going to look at these sentences and I'm going to write an equation using function notation that will represent each of these sentences. So I'm going to use function notation to represent Elena's mood at 11 a.m. on day 1. The first thing I'm going to look at is that it says day 1. Day 1 is my f function. So f of, and my t value is 11 a.m. Now, the scale on my horizontal axis is time since 7 a.m. So I'm not going to go to the 11. The 11 doesn't represent 11 a.m. 0 is 7 a.m. So I need to count from 0 to where I would have my 11 a.m. So if 0 is 7 a.m., 1 is 8, 2 is 9, 3 is 10, and 4 is 11 a.m. So I'm going to write f of 4, 4 representing 4 hours after or 4 hours since 11 a.m. or excuse me, 7 a.m. Now I can also look at my graph and see what that particular output was at 4. So 4 hours after 7 a.m., Elena had given herself a mood rating of 4. So I can write that f of 4 is going to equal 4. And again, that's because at 4 hours after 7 a.m., her mood, her output, was a 4. If I take a look at the second sentence, we're doing this for Elena's mood at 5 p.m. on day 2. Day 2 is my g function, so I'm going to start with g of, and 5 p.m. Again, that's not going to the 5 on my graph. I'm going to have to count to when I have 5 p.m. So remember, 0 is 7 a.m. 5 hours later would be 12. 7 plus 5 is 12 noon. So then if I need 5 p.m., I need to go another 5, and that is at 10. And if I go up to the graph, I can even identify how she rated herself at that time. So we've got g of 10, the input is 10, and her rating at that time was a 5. So here the g is representing day 2, 10 is representing the hours since 7 a.m., so 10 hours since 7 a.m. is that 5 p.m., and her mood at that time was a 5. She was feeling awesome. And we have number 3 here. Use function notation to represent Elena's mood at the beginning of day 3. So day 3 tells me I need to use my function notation, and I shouldn't have written this as h of 3, but rather h of t. I must have been thinking day 3 when I wrote that. So let me adjust this a little. So day 3 is going to be h of t, her mood on day 3. So we're going to have h of, at the beginning, well, that's at 7 a.m. That's when she wakes up. So at the beginning, our input is going to be 0, and she rates herself a 1. So h of 0, that's the beginning, equals 1. That's telling me h is the day 3, 0 is 0 hours since 7 a.m., so that is 7 a.m., equals a 1, which was her mood at the time she woke up. I want to go back a couple of slides here because I forgot to mention that the way we read this notation, and I did say it as I was writing them before, but I read this notation as f of t. I don't want you to confuse it with operations where if you have two variables and you have parentheses around one, that it becomes the multiplication. Function notation is not an operation. We are not multiplying, we're not adding, we're not doing subtraction or division. So when you read this notation, when you know it's a function name, you're going to read it as f of t. The other thing I want you to think about with f of t, that entire expression representing the output, it's just replacing y in our equations. So you're probably used to something like y equals mx plus b. It's the equation for a line in slope-intercept form. I think you may have seen it in a previous class. We'll be working with this yet as we continue our work with functions. But instead of writing it as y equals mx plus b, we're going to write it as f of x equals mx plus b. So we're just putting a name on it rather than keeping it as a y. And again, the purpose for the names is so that we can distinguish one equation or one function from another, just like your name distinguishes you from many other students in the same class or the same building or the same area. And this concludes my video on defining functions and function notation.